Welcome to our ALADYR webinar, Fighting Against Forever Chemicals, an interview with Dr. Mohamed Ateia Ibrahim and ALADYR's Vice President Alejandro Esturniolo.
Hello, Moha, how are you?
Hello. I'm doing very well. How are you?
Great. I will first introduce our guest, Dr. Mohamed Ateia Ibrahim. His research at the U.S. Environmental Protection Agency targets the removal of micropollutants, mostly PFAS, and the assessment of various separation and destruction technologies from lab scale to Superfund sites. Inspired by the realization that conventional water treatment techniques will not be able to treat these problems, Moha has devoted himself to developing practical remediation solutions that draw on his expertise in engineering and chemistry. Specifically, he has focused on the assessment of conventional methods, the development of new materials and/or composites to adsorb or degrade micropollutants, and the mobility of new classes of contaminants in the environment. He has initiated and led over a dozen of research collaborations with researchers across the world to target micropollutants in a practical way. Welcome, Moha. This interview will be conducted between our moderator, Alejandro Esturniolo, and your contributions. Please remember to type your questions in the chat, and we will be happy to read them for you. I will now give the floor to ALADYR's Vice President, Alejandro Esturniolo.
Okay, hello, Moha, how are you doing?
Doing very well. Thank you for the invitation. I'm very excited to be with you today.
It's a pleasure for me to have this meeting with you. It is a very, very important topic. It got my attention many, many years ago, and I consider this is a unique opportunity for ALADYR. Then, to get advantage of the time of our interview, we will try to have the interview in 1 hour. First of all, we will start with the very generic introduction of the topic, and then we will go to the question section. Moha, is okay for you?
Yes, that sounds very good. So, yeah, I prepared some slides, as you said, starting very generic introduction about the topic of micropollutants and PFAS in general. Can you please share my slides there? Yep, perfect. Yeah, so forever chemicals are just like one class. I work here in the Office of Research and Development of the US EPA. My work involves development and evaluation of new treatment technologies for micropollutants removal. And before we start, I'd like to express that many of the thoughts that I'll be sharing with you today are mainly my own, and they don't necessarily represent the views by the US EPA, my current employer. So when we talk about emerging contaminants or contaminants of emerging concern, we are talking about so many different classes of things that are accessing our water sources that they show a lot of concern for us. They have very diverse structures in terms of their chemical composition, and what they share in general that they have increasing concentrations in our water sources. They're persistent, so you don't expect them to biodegrade by microbes in waters or rivers or lakes. Excuse me. And they are toxic, either by design, something like it is designed to be toxic, something like pesticides, or the toxicity can be discovered later for other toxins that they are being found in our water sources. But we should also acknowledge that the magnitude of the problem is huge. In the US, the registered compounds, more than 80,000. In Europe, more than 100,000 chemicals. More than half of these chemicals already in the market, either direct or indirect application in consumer products, etc. So everyone would agree that we shouldn't expect to have a silver bullet here. Means like we need to combine both innovative and traditional treatment technologies to tackle such big problem with that huge magnitude. So among these emerging contaminants, we are talking about PFAS, perfluoroalkyl substances. We're not talking about one chemical. This is something that I always try to repeat over and over. It's a huge family, thousands of chemicals that they have common chemical structure that have carbon-fluorine bonds. So that these chemicals are from the industrial application, from the economic impact. They're good in terms of that they are being used in so many different consumer products. And these are just examples, what you see in that circle, like from painting to fire extinguishers to like paper backing for the food. What does this mean? Like tell us here is that these compounds, they would find so many different pathways to access our water sources and eventually find a way to access our bodies. And they are toxic, and that's why they gain a lot of attention over the past decades, so that we need to find them, we need to quantify them, we need to know where are they coming from, and of course, we need to remove them from our water sources. In the US, this study kind of made a survey about the magnitude of the problem here. And it was estimated that more than 250 million Americans are getting exposed to PFAS in their drinking water. The concentration varies. As you can see on x-axis here, it's a log scale. But what we know so far, that even low concentrations of these chemicals are harmful. Many of them, they kind of bioaccumulate in the bodies and being found in a lot of blood samples. And it is a common thing to say that if you check a blood sample from any American, you'll find PFAS traces in there. So the distribution and the magnitude of the problem, as I said, is really huge. From the removal point of view, I will not talk a lot about this. We can have that in the discussion part, but this is kind of a summary. It's not exclusive, so I didn't put everything here, but these are what you would find a lot of people talking about. So you either separate the compounds from water. Separation methods is adsorption or membrane or fractionation, like foam fractionation. Or the optimum target for us is to degrade them. And degradation, we don't target the degradation of long-chain PFAS. And I can elaborate a little bit on that. Like, as I said, that's a huge family, so they have different structures. And one of the way that people talk about PFAS, you'd have a long-chain PFAS or short-chain PFAS. One of the things when we talk about degradation that we are trying to avoid any byproducts in the formation of shorter chain PFAS, which they are equally or still under investigation, but they are showing similar toxicity in many tests so far. So the degradation, I would like to highlight that part, that our target not only to degrade them to smaller compounds, but we should mineralize them, which means we should get final products that they are environmentally safe and non-toxic. In this regard, the EPA had put already a strategic plan starting from 2021 to 2024. This is an online accessible plan that you can download and read to see what are the currently ongoing projects or planned projects for the near term, and the thoughts that the EPA has for the long term to fight against these chemicals. Beside like that larger scale, each state actually they are taking individual initiatives about setting the limits for what would be the permissible concentrations for PFAS in their water. So there is no regulations yet about exactly what this number should be, but you would find that varies from a state to state. So as I said, it is getting more and more attention, and the topic and the issue, it is very serious that there is planned already activities to be done to fight against that pollutant. This is my last slide. It's just like if you want to read more, that was a paper recently published in Science by several colleagues of mine here in the EPA and also partners either in academia or industry, that they put together a very nice summary about the state of the science and regulations and everything that you would be interested. It's not so long, it's pretty short and concise, and it has also some graphical illustration that you would find also interesting and give a very good summary. With this, I think these are the slides that I have, and we can chat a little bit and answer some questions.
Perfect, Moha. Just in time, 15 minutes. Moha, let's start with the question. We have a lot of questions. We will pick the ones to try to bring more value to your presentation. Camila will read the question. The first question will be from Fernando Del Vigo, Technical Director from Genesis. Camila, could you read the question, please?
Yes. The first question that we have from Fernando Del Vigo from Genesis is, my question is less technical and more of personal concern, and is related to both PFAS and any emerging contaminants in water. My concern is that as they are molecules dissolved in water, there are hardly any physical removal methods for them, but many methods are based on the oxidation or destruction of these molecules, UV, radiation, advanced oxidations, and others. My question is, how can we guarantee that these processes are not generating byproducts that can be even more dangerous than the original molecules?
Okay, it's excellent question. And it is touching based on something that I highlighted in the very first slide. Yeah, PFAS is one class of contaminants, but when we talk about emerging contaminants or micropollutants, we are talking about much bigger problem in terms of the magnitude and everything like that. But to have a little bit of a correction there. So when we say that separation methods are less mature than oxidation methods for PFAS specifically, I think we have the opposite situation. So what we have now, that we can separate them to some extent compared to degraded. So degradation is an issue because PFAS, it has that carbon-fluorine bond, and it is known to be the shortest and strongest bond in nature. So it suggests from the description that it needs huge amount of energy to break these bonds. So what we know so far, that we have commercial or technologies for separation. If we talk about efficient separation of PFAS, nanofiltration or reverse osmosis is very effective. On the other side, if we talk about degradation of PFAS, we have some technologies that they are emerging. but they are getting affected much with the background constituents, either organic or inorganic. But the good news is our analytical capabilities are also getting better and better in terms of the sensitivity and the capture of wider range of PFAS compounds. Why this is important? Because during my presentation, I mentioned about an example of having long chain and short chain PFAS. So some of the technologies for PFAS degradation, what they do, and it is that the question is very correct in that we might be forming byproducts, and the byproducts in that sense would be a shorter chain PFAS. So you just make these long molecules shorter, but you didn't totally eliminate them or like mineralize them, as I said, in non-toxic minerals. So this is the situation so far. We have emerging technologies for PFAS separation and existing technologies, but we have some question about whether they are economic or not. You cannot use nanofiltration and RO for all the treatment facilities, right? So you still the question of having something that it is accessible and efficient at the same time. It's an ongoing effort, but the degradation is of equal importance there in terms of the focus and the need to destroy these compounds before we discharge the final degradation products back to the environment.
Thank you, Moha. We have another question from Giancarlo Barassi, sales and business development in Aquatech. Camila, please.
Yes, the question is, does the EPA has all the contaminated sites mapped?
It's non-realistic to say that we have all them mapped, but we have mapped the sites that we are aware of. I mentioned earlier that the distribution of that contamination issue is really huge. So unless you analyze samples from a specific site, you would be able to say exactly yes or no in terms of the occurrence of these compounds in a specific site. But yeah, it's giving the history, and like PFAS were first used like 8 decades ago, and they have been used without really much care for a long time, which suggests that they would be there in whatever site that it has been used. This is why I'm saying this with a little bit confidence, because, as I said, degradation of these compounds, you wouldn't expect it to happen in nature. So whatever has been PFAS used previously, they should be there. But we mapped as much as we can and whatever we have access to.
Thank you, Moha. Here we have another question from Belén Gutierrez, PhD, head of the Desalination Department and RRD, Director of GS in IMA. Please, Camila.
Yes. There is currently no global and comprehensive legislation related to PFAS that would allow public water systems to enforce maximum limit values for all PFAS substances. This legal void is partly due to the lack of a conclusive listing of all substances, due to problems in detection, analysis, and establishment of validated analytical methods. Thus, what is the EPA's strategy for the development and improvement of detection methods for PFAS in order to have a conclusive list of classification of compounds as well as their detection by water companies? And does the EPA have any proven methods recommended for the detection of specific PFAS? Which ones? Are there any measures within this strategy in the identification of contaminant sources that allow mitigating the problem at the source?
Okay, it's a long question, but I can dissect it a little bit. So saying that we don't have methods, I would say no, we do have methods. EPA specifically, we have published method that anyone can access and use. We have methods for drinking water samples. We have methods for wastewater. We have method for PFAS in solid samples. On our website, you can literally just search that and it will pop up on your search engine, and you can access in very fine details about these methods. Beside these, we have also a lot of efforts are ongoing for PFAS analysis in other media, like in tissues, in blood samples, and others. They are being either under development or validation stage. So whenever these are validated, we will also be putting them publicly accessed on our website. So we have methods that they are actually now even expanding in terms of the number of PFAS that you are having under these methods. So this is for that part. Beside the things that we know in terms of, so let me explain it in an easier way. So when we are detecting or measuring PFAS or developing a method, we need to have a standard solution for it, right? So we are limited by that to some extent in the what we call it the targeted analysis. So you have a standard solution for your target compound, and you develop the method based on that. So as obvious, you'll be limited of how many of these standards are in the market. So that's one part. So this is targeted analysis. Beside these targeted analysis that I said we have for drinking water, wastewater, and solid samples, we are devoting a lot of efforts for what we call non-targeted analysis. So it involves some of machine learning techniques to discover samples, PFAS in samples. So it's not really quantitative, but it is more qualitative to know that certain structures are there. So this is what we call non-targeted analysis, and it is a heavy focus for us, and it's an ongoing efforts. And again, once a validated method is done, it would be published. Beside that, we have another method or another technique which would fit what was mentioned in the question about a treatment facility, because the targeted or non-targeted analysis, it needs specific techniques and it needs expertise to some extent there. But we are developing other methods that target total PFAS, total organic fluorine, and similar methods like that would fit like a bulk analysis of PFAS. And these are also ongoing efforts and taking a lot of attention from us. In terms of finding the sources, it's a work in progress. We are trying to identify that on parallel with developing and validating analytical method that would help finding and tracking the sources of that contamination.
Perfect. I can see that we have at least 10 more questions than we received before the interview. Then
okay, I will try to.
It will be tough. Next question is from Thiago Barbosa, Latam Water Business Development Manager, BNP, from the group BEG.
With the advancement of PFAS sensors, how artificial intelligence AI can help this control to become even more efficient?
Okay, need to highlight first, advancement, maybe it's a big or generous description to the current situation. Like there are some publications that they are working on PFAS sensing, but they are still in lab scale and targeting very limited number of PFAS compounds. I said I love repeating that because I need to repeat it in situation where it fits, because we're not talking about a one compound, we're talking about a family of like thousands of chemicals. So having a sensor, it like from its name, like you want something that it is sensitive to specific structure, or it can capture something in low concentration. And that's another issue, like PFAS, as illustrated in the figure of the impacted population in the US, that most of the concentration in low range, nanogram per liter. this is like 3 or 4 orders of magnitude of other background constituents, dissolved organic matter, anions, anything that you find in your water or wastewater. So there are some steps, but I think it needs a lot of careful evaluation in terms of like, yeah, sensors mean they're sensitive to something. So what is that thing? So which compound or group of compounds that they could sense, and what is the media or the background media that they could evaluate it. But the question mentioned about AI, which is a very good touch, because as I mentioned about the non-targeted analysis, I think coupling these might open other possibilities of like prediction to like yes or no kind of occurrence of specific structures. So, but I'm not aware of anything that has been published or validated so far on that line. But it is possible. Yeah, it is possible. But is it there? I don't think so.
Yes, it's not that easy to control more than 5,000, 8,000 species, different concentrations. I think we should work more focusing the barrier to be sure that about this, how safe is the barrier than to control the feedback, the feed water.
Exactly.
Yeah. One more question. This question is from Manuel Garcia de la Mata, General Manager, South America at Fluence Corporation. Camila, please.
I have read in some papers that we can find PFAS substances in microplastics. Do you know if microplastics can release PFAS into our body when ingested? Does the EPA consider this issue when it refers to this water contamination?
This is an area that it is not really developed yet in our understanding, or what is the magnitude of absorption and the consequence, like that. What's the next step? So you're talking about the low concentration in your water source that you're expecting to get stuck on a microplastics, which is, yeah, there are some papers here and there about the affinity, but what you would be caring about from health perspective, how much is the contribution of that specific class of another contamination, which is microplastics, that it is contributing in moving PFAS in our bodies and dissolve there. So short answer, we don't know. And as I mentioned, like there are much more other priorities before we get to such very niche area of toxicity.
Yes. The problem with the microplastic is that we can wait 50 more years to see what happened in our body with this kind of contaminant.
I think the question was talking about that pollutant will get absorbed on microplastics, and because of the abundance of microplastics and the evidences that they are being released about, even there is a paper that's published a couple of weeks ago that they found microplastic samples in blood samples, which is scary. So I think the question was talking about how much is the contribution of microplastics absorbing PFAS, and then both of them going to the body, and then once they are in the body, they get released in the body.
Yes.
And cause toxic effect. So you see, it's each step you would have like a lot of unknowns and uncertainties there, which we don't understand or fully evaluate it in a precise way.
Thank you, Moha. Next question from Brazil, Luis Becerra, Industry Technical Consultant.
Has the EPA detected if water containing PFAS can be transferred to food by irrigation?
It's similar to microplastics in a way, but it is actually, yes, that transfer of PFAS climbing in a food web, it is still something that we have a lot of uncertainties there, because you have interactions between PFAS and plants themselves. How much is that's happening? We don't know the answer as a certain answer for that.
Yeah.
But on the same line, there are also some questions about the contribution of something like biosolids coming from wastewater treatment plant, and it has some PFAS. So that also, it's not only from irrigation water, there are
The
some
sludge.
questions, but yeah, coming from solids that you add as fertilizer, but it might have some PFAS, but there is no conclusive evidence or answer about that contribution yet. But I'm saying it just to let you know that these questions are also some groups internally are looking into that as well.
But this is a very very important question, because in other part of the world, or including in United States, we are thinking about the next step for reuse. Irrigation, as you know, is very very important in terms of quantity of water. 80% of the water in the world, we are using that word for irrigation. Then the specification, actually the European Parliament approved 2 years ago the wastewater treated as a source of irrigation for wastewater for agriculture. Then if PFAS is a problem in that regard, we have a serious problem, because we are promoting something that we don't know what will happen in the future. The same with the sludge. The sludge is something very strategic for some countries to in agriculture, but we know that that we have that contamination in the sludge.
So here is my take on that. That your points are valid and can be true, but the good news, just like, don't want to just bring bad news that we have everywhere, that these are being evaluated now. So I'm aware of some sites that they have legacy addition of biosolids and being compared to sites that they have fresh addition, and comparing to the concentration there and the mobility and everything. So it is taking very serious consideration. A lot of funding coming either from EPA or from the Department of Defense here to answer such questions. So I share your concern that that it is something that we should take care and answer. But again, the good news that these are ongoing efforts, and I think we should have more insights very soon.
Thank you, Moha.
Yep.
We have another question now. Is from Guillaume Claret, Chief Operating Officer at H2O Innovation.
RO and IX are removing PFAS but not destroying them. There are, however, some promising destruction methods using electrodes, anodes, and cathodes. Any insights you can share around the most promising ones you have seen?
It's tricky, just because I should.
You don't know Guillaume. You don't know Guillaume. I know him very well.
Yeah. The concentrated waste streams from RO or nanofiltration is a big concern. It is similar for the regeneration solution from ion exchange resins, because you have a messy situation there. It's very concentrated waste with a lot of organic, inorganics, and everything else beside PFAS. Is there something that works? Personally, I'm not aware yet. There are a lot of proposals, there are a lot of ongoing efforts. I know many groups around the globe that they are trying to solve that. My group here in the EPA is actually targeting what we call hard-to-treat waste stream. Hard-to-treat waste stream includes the regeneration solution from ion exchange resin and the retentate from nanofiltration, for example. And we don't have a final answer yet, because each technology that you test, you will find some deficiencies. So how to answer that question in a more constructive way, you would need to take it as a case-by-case scenario. We don't have, I will borrow from my slides, we don't expect to have a silver bullet. Okay, I will come to you in an interview and say like, yeah, this is the technology that everyone should use. It is impossible to do that, specifically as the complexity is now is very clear. So the efforts now going to like now towards what we call a treatment train. So you would have a case study, a site, and specific issue. So like as any consultant, right, you will get some site specification, water quality data, and based on that, you will say, okay, we will have a treatment train, the membrane, activated carbon, or whatever. So this is a separation step. And then what are the byproducts? So you have PFAS on activated carbon, and you have PFAS in regeneration solution or something like that. And then, okay, how to deal with that. So that treatment train will be, I guess, a case-by-case scenario. So, and that's why we don't have a global answer for that. Some technologies are showing some promises here and there. Yeah, electrochemical degradation is showing some PFAS degradation, but you need to look closely how they evaluate it. What are the conditions? Is it like something that you would find in a landfill leachate or an ion exchange regeneration solution, or it's in a drinking water where the competition from the background is very minimal? So I needed to give that long answer just to highlight that it's much complex scenario than just like, here is your wild card, this is the technology that you should use. It doesn't work like that.
Thank you, Moha. We have a question from Fraser Kent, PhD, Vice President of Technology at H2O Innovation. Please.
PFAS are known to be extremely persistent, and the technologies currently applied for PFAS removal have residual streams that are laden with PFAS. What is the EPA's advice for final disposal of these concentrated waste streams with PFAS-loaded ion exchange and activated carbon media?
I would need to carefully answer that. I am not saying that the EPA advised by that. It's again my personal perspective on that issue. Solid waste, liquid waste, they as I just said a minute ago, that it will be like a case-by-case scenario. But to be realistic, we need, if we want to solve a short-term issue, we need to have access to what is the most efficient technology now. So if activated carbon is being used because this is what you can buy from over the shelf and use it either in a point-of-use system or in a treatment plant. But as the question said, that you would have a residual stream of solid waste, which is a PFAS contaminated activated carbon. What's happening now is it's either sent to a landfill or it's incinerated. What we do is now we are trying to evaluate the incineration part, to revisit it, to make sure what are the byproducts. I think it's linked to one of the earlier question about how can we make sure that there is no byproducts. We are not aware yet of a final answer to that, but this is something that we are taking a step back and compare to other technologies. We're trying to push to be more mature and more like in an application phase. We are looking at something that you have incinerators all over the place, right? And this is what people would have access to, just get rid of their solid waste. So that's why we are, for that specific scenario, we are taking a step back and trying to go to more fundamental research, how it is being degraded in an incinerator, what are the conditions, what are the effect of like unoptimized condition, because they are not designed for PFAS, right? But what are the byproducts are being formed, if any? This is something that we are literally working actively now, and hopefully within a couple of years we can get some more answers on that. So yeah, sorry that I couldn't answer that directly, because again, we don't have any conclusive answer there, and that's why it's very exciting for us, because it's an open question, and once you have an open question for a researcher, that it's something that people need to know the answer, and this is what we're trying to do.
Thank you, Moha. No, you are doing an amazing work, and the world is following you guys with the EPA with this, because we are saying, we are communicating that United States, most of the people is with PFAS in the blood, but at the end of the day, the other places, all the places in the world, nobody is analyzing this. Then it's something that we should promote worldwide.
Yep.
We have two more questions from our president from ALADYR, Juan Miguel Pinto.
Yes. Certain PFAS are no longer manufactured in the US due to phase-out plans. What would be your advice for Latin America to begin to establish measures in this regard? What would be the first step based on your experience?
It's a very good question, and it is relevant to why I'm so excited to have this interview, just like raising the awareness. And the major point is that we don't need to reinvent the wheel. We have a lot of existing knowledge that took literally decades of a lot of advancement of our understanding, a lot of advancement of our analytical techniques that has been developed. So the advice is just like see what is out there and try to adopt that fits your societal and economical local state. So again, there's no validated package for fighting against that pollutant. It needs to be taken with consideration and very much care to see what fits the community, what is actually needed in the community. Is it mostly abundant in solid? Is it mostly abundant in water? Is it both? And for each scenario, you would be attacking it with different perspective, right? So the things that can be transferred can be knowledge, as a lot of policies, we don't have any regulations, but we have a lot of communications out there, how people are talking about it, how things progressed from we don't care at all to no, it's a serious issue. So we don't need to take it from the very beginning. We can see where the world is standing, and we try to learn from that. And it can be very technical. All the methods that I highlighted earlier. So researchers in Latin America, they don't need to go and develop a method from scratch. It can be literally just access the EPA website, and I want to evaluate PFAS in this media, liquid, solid, and what is the good method, what is the needed technique. So you can see now you are taking already developed methods or knowledge and try to adopt it to your local state. Or it can be behavioral. So behavior, it means like some mitigation. So people now should know more about this contamination, where they are coming from. So we're not talking about point sources, like we're not talking about factory, but I showed you a figure, like it can be used in a lot of consumer product that people are using it day to day. So the behavioral change can be adopted in terms. People should know that now a lot of researchers, a lot of companies are moving away from PFAS and developing alternative chemicals. So they can literally see which product is using PFAS and avoid it, and what is being used with a safer replacement chemical, and they start using it instead. I'm not saying that as as an example that exclusive, but it is very common. I mean, it doesn't need to be Latin America. We have it all over the place. The Teflon pan, it's just like the non-stick pan that you use for cooking. This is based on PFAS technology. That why it doesn't stick, it is because of the PFAS compounds there. They are very highly resistant to heat, and they give it the non-stick nature. It can be in the popcorn packages, or even they found in a lot of packaging for fast food that you buy. So that awareness, that development of transfer of the knowledge from the literature, from the media, from everything, that can be delivered, ready to be adopted in a new society.
Thank you, Moha. It was the reason of our interview today. Obviously, it's a worldwide interview, but our main focus was to share with South America, Latin America, about this. And again, we don't want to invent the wheel, again, for sure, no doubt. Camila, do you want to start with the question of the audience on our right in the comment? Maybe we could start with the Sultan Ahmed question. And maybe it's a tricky question because what percentage of PFAS can be removed using RO? Maybe depend of the membrane and depend of the PFAS.
Nanofiltration RO, they are very, very efficient. I mean, they can remove very high percentage, more than 90%, I would say, safely. Maybe much more, but I mean, giving it that ballpark, it's safer.
Yes, but having a limit, let's assume 70 ppt, this 10% or 5% that we are not removing maybe is too much. All depends on the source.
What is the influent concentration? Are you removing it from? Maybe it's a good scenario here to share. So you have drinking water condition, which is in ppt, nanogram per liter level, but you have contaminated sites. So one of the major sources for PFAS is what we call AFFF, the aqueous film forming foams. It is being used by military sites for to suppress the fire, aviation fuels, and a lot of military applications there. Why I'm saying this, because these places, and with that use of large amount of PFAS containing liquids, they penetrate to groundwater, and these groundwater would have like microgram per liter level on in high range. So this would be exactly what you are referring to, and it will link to what are the future regulations, because if the regulations are single-digit nanogram per liter from 1 to 9, then if you are removing 90% out of 100 nanogram per liter, yeah, you're still above that, or did you meet the requirement or not? So it's again the same point of a case-by-case scenario, where it is going, is it the drinking water or it is wastewater? But for the original question, nanofiltration RO, they are efficient. But remember, they are efficient so that you would have a lot of byproducts in the side waste stream, the retentate there. This is a highly concentrated solution. What are you going to do with that? You should take care of it.
Okay. Camila, we have one more question from Juan Miguel Pinto, I think.
We do.
Sorry. Yes, I started with the... Okay, please.
Okay, he's asking, regarding the removal of PFAS from water, what type of technology is the most effective according to your experience?
I think everybody is expecting maybe we should add a publicity right now.
Everyone wants me to say a magic word. Yeah, we have, but we don't. I will repeat it because it's important. What we have in a mature level in terms of the technology development, you have nanofiltration RO. Is it economic for everywhere? This is a case-by-case scenario. You have activated carbon, and you have ion exchange resin. I'm talking now about the separation technology. So this is, again, effective to some extent, but they have some deficiencies. Like many of these, either you have like a side waste stream, like a spent activated carbon or ion exchange resin with PFAS on them. What are you going to do with the solid waste? And the more serious part is that they are not really effective with short-chain PFAS. They are more hydrophilic, hard to remove. On the positive side, that we have some ongoing efforts, things in the development stage, more selective or adsorbent with higher affinity to PFAS. This can be like cyclodextrin polymers or more aminated materials that they are now being tested in various scales, but they are not ready to be used in the market. So that's the positive side. Like we have learned a lot over the past few years about what PFAS like and dislike, and how can we develop a material that it is selective or have higher affinity than activated carbon and conventional materials. So this is on that part. So separation technology. And then I mentioned earlier that we need a treatment train. So after separating it, what will you do with the solid and liquid waste that results from that technology that you picked? And we don't have a silver bullet. So I will stop here from repetition because I said that already.
Thank you.
Yeah.
Camila, do you want to pick a question? Because we have 4 or 5 more questions and we don't have enough time.
Okay, we can go in order. We have the question from Corey A. Cooper, MBA. Is incineration of PFAS going to be a viable solution going forward? Or will more regulations make PFAS incineration a non-viable solution? I know that there are some ongoing air emission analytical models that are under development that this issue involves around.
Yes, thank you for the question. I will be brief because we don't have that much time. But I think that the answer is in the question. They are ongoing efforts. We don't have any conclusive evidence that they should be stopped, or what is the magnitude of, as you said, like the air emission of whatever byproduct that might be formed. But I said it again, just for comfort, because it's a good piece of news that it is taking huge amount of attention internally, that we are trying to go both fundamental and beside the development for capturing air samples or analyzing these samples to know what are the byproducts or the final products, let's say, from that degradation technique.
One more, Camila?
Thank you, Moha.
Place for 2 more.
Yes. Dietelm D. Stuit is asking, good morning. Are there any known biologicals that will break to carbon-fluorine bond?
There are some very recent, very active area of research about biodegradation. There are some separated strains of bacteria that they showed to be degrading PFAS, or but there is no final answer on that. I mean, like, I guess NIH funded some work on that recently. So there are, but how is the practicality? Is it like something that we can scale up easily? They are still work in progress, and there is no conclusive answer about it.
Thank you, Moha. We have a question from Julio Fuchs. What do you think of the indirect methods of evaluation of organic fluorine?
Indirect method. Yeah, I think I mentioned that as what we call the total organic fluorine or other similar methods. It is very important, and we are working on some development in that direction, because it covers one of the most important aspects of PFAS, and it is the magnitude of the number of compounds there. So we wouldn't be able to really say what's in there, but if we have a method that it is sensitive enough in terms of like separating the background fluorine from the organic fluorine that comes from PFAS, and then say that you have X unknown of PFAS compared to the known PFAS that you measured from a direct method, this is a very big win in the field. So it is very important point. We are working on it, but still work in progress.
Thank you, Moha. We have 2 more questions. Do you use TOC to trace these compounds and diagnose peaks of contamination? This is a question from Gustavo Vergel.
TOC, I would say yes and no. Yes, in a lab setting where you have like a nanopure water spike with PFAS and try to quantify or make the mass balance. Now the researcher inside me is talking now. So we are using it. I'm not saying that no one is using TOC. A lot of the work that we did with the photocatalysis, for example, but it's very simple that it cannot be generalized. And why is that? Because if you go to a real water sample, you'll have TOC coming from much bigger molecules and much higher concentration, which is the dissolved organic matter and other micropollutants in the background. How can you really distinguish that this is coming from PFAS or no? In the real water sample, it is almost impossible. So we use it for a specific case, research focus to answer very, very specific question, and it needs to be combined with other technologies like direct analysis of the compound and, as I said, try to make the mass balance of carbon atoms there. But on a realistic real water sample coming from river, lake, wastewater, it's impractical.
Thank you, Moha. The last question comes from Nicolas Stark. Interesting presentation. Have you been able to develop a PFAS removal plan? That is, development of diagnosis, affectation map, and potential effects. Action plan?
I don't think I can really talk about that, but this is what I described as how we should all be attacking this point, is that we will talk about a case-by-case scenario, a specific site or a specific issue in a state or a country or anything. River that is contaminated, lake that you want to decontaminate it, and then you would be developing methods for that, and then see what are the accessible, economical treatment solutions, and then what is the degradation method that you'll be adding to totally decontaminate the site. So we have that kind of workflow that we follow, but again, we don't have one workflow that will work for everything.
Okay, Moha, the rest of the question, if you don't mind, people, we will reply it by email, or maybe we could add in our account in LinkedIn. We will find a way to share that information with the audience. Moha, I want to thank you again. It was a big pleasure to talk to you. You are always open to share information. You don't know Moha, people. He's a very good professional, always helping people, sharing information, writing articles. And we don't know how to say thank you. I hope to see you in person. We've never been in the same table, man. But thank you so much. Something that you want to share? A lot of people.
No, I want to thank you. These initiatives I really like, because, as I said, raising the awareness is one of the easiest thing that we can do for everyone. Like, we cannot give fund, we cannot give analytical capabilities, but just letting people know that this contamination is there, they should take care, where can they find it, how can they avoid it. I want to thank you for helping raising the awareness about that. Regarding the more questions, you can email me, you can send me on LinkedIn, you can send me a DM on Twitter. As Ali said, like, I'm very accessible. Just let me know if you need any help, and I'll try my best.
Thank you so much, Moha. Thank you everyone to participate in our interview. And for sure we will prepare something else in the future. Thank you so much.
Thank you.
Bye, Moha.
Bye.
Hi, and welcome to GWA Water Data. GWA Water Data is a completely unique strategy validation tool for companies with exposure to the international water industry. It pulls together all GWA proprietary datasets and provides easy access to key public and third-party datasets. It's a dynamically updated service that develops with user needs. It is to water industry executives or to Bloomberg terminals to a fund manager. GWA Water Data offers 3 unique things: market metrics, market dynamics, and market access. This means that for any market in the global water sector, it will tell you how large it is, how fast it is growing, and how you can access it. You will find market metrics via the global 5-year forecasts, which can be broken down by technology, application, chemical type, and more. Country profiles also provide granular market data, and you can access comprehensive third-party datasets, industrial data, and financial data through the extensive resources database. Information and market dynamics is available via the company's dashboard, which shows corporate activities including live and historic M&A activities. Technology developments, including trends in established and emerging technologies, are also profiled, and the position of companies or technologies within the market can be found through over 800 company profiles and market maps by technology. Finally, GWA Water Data will help you to plan your route to market by finding potential clients, partners, and projects to bid on. How does it allow you to do this? GWA Water Data contains comprehensive water and wastewater utilities and treatment plants databases. It tracks upcoming opportunities based on sector structures and regulations, and it categorizes market participants by region, allowing you to check local partner profiles and profiles of technology companies. Data is constantly updated to make sure that you are always up to date with the latest information to enable you to make the best business-related decisions in the industry.